Let's do section 10.4, page 515, exercise 3, which reads, use a comparison test to show that the series converges for all x. And for exercise 3, the series is the summation from n equals 0 to infinity of x to the 3n over 2n factorial plus 1. So let's start by reviewing what the direct comparison test says. If every term of the series an is less than every term of the series cn, and cn converges, then an will converge as well. And this is a pseudo sandwich theorem, that if everything is going to be less than cn and cn converges, an has to converge too. Conversely, if every term of the series an is bigger than every term of the series dn, and dn diverges, then an is going to diverge too. So let's go back to the problem. What we need to do is find a series that converges that has terms that are greater than the one that we're looking at here. Now, I would be suspicious that this a to the 3n might be part of a Maclaurin series. So let's write out the first few terms here. So we're going to have 1/3 plus x cubed over 3 plus x cubed squared over 5 plus x cubed over 13. And of course, this is going to continue. And that x cubed that's raised to the 0 power and the 1 power and the 2 power and the 3 power kind of reminds me of the series for e to the x. And e to the x is equal to 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And we can sum that up as the summation from n equals 0 to infinity of x to the n over n factorial. So what if we wrote this series e to the x cubed, which means that everywhere that we have an x, we substitute in an x cubed. So this would give me 1 plus x cubed plus x cubed squared over 2 factorial plus x cubed over 3 factorial. And that series, of course, continues. And I can write it as the sum from n equals 0 to infinity of x to the 3n over n factorial. Now we can see that every term of this series is going to be bigger than every term of that series. How can we see that? Well, let's just focus on the nth term for a moment. Now the nth term of our original series is x to the 3n over 2n factorial plus 1, and that's going to be less than the nth term of our e to the x cubed series, which is going to be x to the 3n over n factorial. Now, because I know that n factorial is going to be smaller than 2n factorial plus 1, and those factors are both in the denominator, that means that this series is going to be bigger. Now, because this series converges to e to the x cubed for all x, and because the terms are bigger than the terms in my original series, I know that my original series is also going to converge for all x.